We are going to solve kth largest element in array. This question has been asked in a lot of big tech companies like Meta, Google, Microsoft. You can see all the big tech companies name here. This question we are going to solve using min heap. Min heap is implemented using priority queue in Java. So I'll use priority queue class for implementing this function, implementing this solution. Okay, so without a further ado, since this is a short question, we'll directly jump to the question. Question says basically that you are given an integer of nums array and an integer k also. You want to find the second, kth largest element in the array. So in this example, it will be the second largest element will be 5, right? And in this example, the second largest element here would be, okay, so the fourth largest element here would be 4, right? Because you want to find the kth largest element, not the kth distinct element, not the fourth distinct element. It's not like the four distinct elements. You have to find the fourth largest. So this is the first element, this is the second, this is the third, this is the fourth, right? So that's why the answer is 4. And you can try to solve it without sorting. So if you do it via sorting, if you just sort this list, you can find that index, and it will index that is like k minus 1, and then you will find the answer, right, if you use sorting. But you want to do it without sorting. So this is an introductory question for solving a question using priority queue, right? So by default, a priority queue in Java is a mean heap. By default, it is a mean heap. What is a mean heap basically? So mean heap is something that will store elements inside it, but the top element of the mean heap will always be the smallest element of the whole bunch. So basically the top element is the smallest element. The other element that are below this smallest element doesn't guarantee any order, right? So are they that in decreasing order, or they are in increasing order, it doesn't matter. It's just that it will always store the minimum element number in the heap. So how can I use this property to solve the kth largest element, right? Solve the kth largest element. So we'll go with an example. Okay, I've already written that min heap stores lowest number in the peak, right, at the top. So I have already a list of array, and I want to find the second largest element. By seeing in the question, we can say that 5 is the second largest element, right? But how we will solve it, right? So I'll have a, so we want to find the second largest element. Second largest element. Okay, so if I have like an array which will store only 2 elements, it should store the second largest element and the largest element inside it, right? So two largest element of the whole bunch, but second largest element I need access. Okay, right. Now let's say that I have a heap memory, right? I have a heap memory here, and I'll store digits one by one, but at a condition where my minimum element that is in the heap, right, it should be larger than the upcoming element. It should be larger than the upcoming element. If the element found is larger, then it will replace it with the mean heap, right? It will try to get added, and we will just replace it. So to draw this solution basically, right, so first I'll have 3 and 2 inside, so I'll iterate over, but I will find 1. I'll check what is the minimum element. If this minimum element is like less, right, then I'll not replace. If it is more than the new element, then I will not replace, otherwise I will replace. So the sequence would be 2 3, I'll check 1, it will not replace, I'll check 5, it will replace. Okay, so now if I 5 replaces, right, according to me priority queue property, the top element will be the minimum element. So now the new element will be 3 and 5, right? Then I have 6 will replace 3, so now it will be 5 and 6, right? Now I have 4. Can 4 replace the minimum element? Is it greater than the minimum element? No, it is not. So I'll have 5 and 6 in my priority queue. And if I do a peak, right, because what min heap does is min heap offers you some methods, like it offers you a peak, it offers you offer, which is essentially add and reshuffle together, and it offers you pop, which is basically removal of minimum element. And this is a view, like if you want to check what is the minimum element, you can use peek, right? So these are like the three very very important methods that can be used in priority queue. So going to the solution for this, okay, so I'll iterate through the array, and I'll try to add numbers in my priority queue, and I'll try to only add two elements inside it. So once I have two elements, I'll continue, right? Now if let's say I have another element where the size is more, right? So the size is becoming more, right? So what I want to do is I want to replace the minimum element, but I want to replace it only with the element that is greater than the minimum element. So the new element, if it is like greater, if it is greater than the minimum element, I'll remove the minimum element and I'll add it. So this will reshuffle also. So eventually, from the example where I showed you, it becomes 5 and 6. We can use the minimum element as an answer. So I'll do min heap dot p. Simple enough. So essential thing here is to note that priority queue will have the first element as the smallest element, right? You have methods like size, offer, peak, poll, and peak, poll, offer, and size, which will be very useful to manage a priority queue. By default in Java, when you declare a min heap like this, right, via the priority queue class, it is a min heap, it's not a max heap. So for a max heap, I'll have a separate question where you need to identify, where you need to define the sorting order. So let's say if I have two elements like a, b, if I do a minus b, it would be smallest order or decreasing order, right? The smallest one will be the first min heap, and if I do a b minus a, then it would be a a maximum heap, right? So anyway, that we will come across in the next question when we find the kth smallest element, maybe. Yeah, but other than that, this is a solution for that. Just remember that the priority queue will hold the minimum element as the peak element, and you just need to check with the minimum element always. One of the property of a array, if you notice here, is if the size is k, the other element which will be greater than this element, right, our element will always be k minus 1, right? So if I have like 3 as a size k, so if I have one smallest element, the third smallest element, then I will have other two as a larger element. If I want to store a larger element, I always want to compare the upcoming element with a peak element, right? That's how you find it. Okay, so the tip here is to remember the three methods, right? Offer will add element and it will refresh the heap, reshuffle the heap. Poll will pull or remove the min element, and this will only check, or it will return the min element. Okay, so thank you for watching this video. Stay tuned for the next question where I will tell you more about the max heap. Okay, thank you so much. Bye.